I'm really very glad to have with us today Anastasios Skarlatidis, who has been working with us for a very long time and before joining Pollfish. I'm really glad that we get to hear about Pollfish because I have always believed that they have a very interesting business model regarding the way market research is being conducted. And the data that is collected through this market research activities is very interesting, and I'm sure that Tassos will tell us what they do with it. So Tasso, thank you for accepting to present to us what you're doing, and please try to keep to your presentation to about 30 minutes so that we can have a bit of discussion afterwards. It's usually very interesting at the end.
Okay, so let me share my screen first to start the presentation. Okay, do you see my screen?
Yes.
Oh, nice. All right. So, first of all, I would like to thank you for inviting me to the AI Industry Connect Talks. It's also a pleasure to meeting you again, George, after a long time, and presenting to Anastasios and Demokritos. I'm Anastasios, and I'm leading the data engineering and science team in Pollfish. So in this talk, I would like to present you the Pollfish Survey Platform, and more specifically to give you an overview of how methods like optimization, local search, or statistical analysis, machine learning, and even event processing have been applied to Pollfish in order to give better insights and make market research methods accessible to anyone. So a little bit about Pollfish. Pollfish was founded in 2013 with the aim to create a complete survey platform for market research using mobile and web technologies. Nowadays, Pollfish is a remote-friendly company and still operates 2 offices. Offices for product and engineering are located in Athens. Sales and finance offices are located in New York. And a couple of months ago, we had some exciting news. Pollfish has been acquired by Prodigy, which is a US-based company for marketing and consumers insights. So Pollfish is an easy-to-use, do-it-yourself survey platform for market research. You can create a survey and get responses across 160 countries. The platform gives you the ability to adjust demographic, geolocation, and mobile usage criteria. And on top of that, you can set up advanced market research methods like A/B testing, conjoined analysis, and max diff. To achieve that, Pollfish integrates with mobile and web applications, as well as with other third-party survey networks. So in contrast to traditional survey platforms, Pollfish does not have panels, and the audience is completely dynamic. We do not have subscribed users in our platform that answer surveys. Instead of that, we are pushing surveys to integrated applications, and the users of the apps choose to answer the surveys. Now, just let me give you some numbers first. Pollfish so far counts total 6,000 clients. Among them is Booking.com, McAfee, BBDO, HubSpot, Decent, Cliff Bar. The platform so far has been integrated with more than 140,000 applications and also connected with 15 third-party survey networks. The platform can target audience using 25 different criteria. For example, the past year, we had more than 50,000 surveys completed. And from those surveys, we had almost 6 million survey participation. And every day in our platform, we see around 5 million unique connected devices. And all of them are producing around 80 million or more events to our platform. Regarding the data software stack, the main programming language that we use is Scala. Also, we use Python specifically for statistical modeling and machine learning. All microservices that we implement are deployed in Kubernetes, in Google Cloud Platform. For exploratory data analysis and batch data processing, we are using Apache Spark. We also use a lot of streaming data, and we are using Flink, Kafka, and Akka streams. For machine learning, mainly we use Spark machine learning library, and also in some cases scikit-learn. For data storage, we have data lakes in Google Cloud Storage. And also we use several databases such as Druid, Cassandra, Elasticsearch, and Postgres. Now, before diving into the main topics of this presentation, I would like to explain some important terms first. So, as we can see here, on the one hand, we have the researcher, and on the other hand, we have the respondent. And the researcher is the person that wants to perform market research. For example, to create a survey about a product or a service. That survey is being distributed from Pollfish to integrated applications in mobile devices. Users of those mobile devices that answer the survey questions are the respondents. And finally, after collecting the answers, the researcher can analyze the result. So Pollfish sits right in the middle and gives the ability for the researchers to create survey questionnaire, and then Pollfish distributes the questionnaire through the integrated applications to potential survey respondents. And also Pollfish collects all those responses in real time in order to provide all the collected answers for data analysis. Now, the rest of the presentation is being separated in 3 parts. That separation logically represents the 3 main phases that are taken from survey creation to data analysis. So, as we can see here from left to right, we have the survey creation steps in which the researcher uses our platform to create the survey. The second part is data collection. So here, Pollfish distributes the survey to the right audience and also disqualifies any bad quality or fraud participation. And on the last part, there is a data analysis in which the researcher can explore, filter, and export collected responses. I would like to also highlight here that I will follow a little bit different flow in the presentation. I'm going to talk about survey creation and data analysis first, and then about data collection, since data collection, it runs on the background and does not involve any action from the researcher. So let's begin with survey creation. Imagine, for example, that you are a researcher and you want to perform research about your company's product or a service. So once you have created an account to Pollfish, you can immediately create a new survey project. And the first thing that you do when you create a project is to specify the right target audience. For example, for which age ranges that you are interested for, country, income levels, educational levels, and so forth. And at that particular moment, Pollfish will help you by giving you useful insights. For example, if the specified audience is feasible or not in our network. So to illustrate this, as we can see here in the screenshot, you define how many people should participate in your research. For example, 400 here. You create one or more audience groups, and on each one you specify the desired demographics like age ranges, income, and so forth. And also you can specify geolocation criteria like countries, cities, postal code, or even give coordinates and some radius in kilometers or miles. And all over these targeting criteria, you can also add quotas. For example, let's say that you are targeting 2 cities, Athens and Thessaloniki, and you have 3 different age groups. And for your survey, you want that all those criteria to be equally distributed. So 50-50 between the 2 cities and 33.3% for each age group. While you are defining the audience, Pollfish will let you know if that audience is feasible to be found in our network. And also it will give you an estimation of how long it will take to collect all those responses. So for example, for that particular case, we have an estimation of 7 days. Additionally, Pollfish will provide you with an estimation of the distribution for some key demographics and geolocation criteria. So before taking the survey, you're going to have an estimation about the age ranges, the educational and income levels, or geographical criteria like cities, states, and so forth. Now, we're going to proceed a little bit deeper about the audience targeting. Since Pollfish does not have panels and the user base is completely dynamic, the audience and feasibility insights may become challenging. Specifically, as time evolves, the amount and the distribution of the observed demographic and geographical data changes. So it is a kind of stochastic process. Consider, for example, the distribution of age ranges and the amount of the audience for the past 24 hours. It might significantly change on every passing hour. Audience preview should able to give an estimation of the distribution for key demographic and geographic criteria, given any other specified targeting criteria on your survey. For example, let's say that you are targeting specific countries and specific income levels. So it should give you the distribution of any other criteria, how it's going to be changed. To achieve such estimations efficiently, we are using Apache Druid in order to have an online analytical processing storage over time series of data. And Druid has an advantage of giving fast, approximate cardinality estimations using hyperlog sketches. And like any other OLAP storage, we can apply any targeting filter to our metrics and any custom measurement that we like to perform. Now, however, this may become even more challenging when we have quotas to one or more targeting criteria, because in the presence of quotas, any other criteria distribution should be adjusted accordingly. Let's give you an example. As we said before, you are targeting Athens and Thessaloniki, and you also have specified 3 different age ranges. And you would like that both cities and all the age ranges should be equally distributed. However, if we do a measurement based on recent estimations, for example, the past 30 days from now, we might observe that the sampled distribution of cities is not 50%, but it is 61 for Athens and 39 for Thessaloniki. And similarly, the three age ranges are also not equally distributed. So Pollfish here uses an optimization algorithm to automatically stratify the sample distribution in order to satisfy all quotas together. In particular, we are using iterative local search procedure, which is a modified variant of the raking algorithm, also known in the literature as ring weighting or iterative proportional fitting. So by applying the user-specified quotas, the distributions of any other targeting criteria will be adjusted accordingly. And therefore, we can give an estimation of how the resulting distribution, the adjusted distributions will look like. Now, regarding feasibility, we are interested to estimate either the number of possible completes in some desired interval of time. For example, how many completes can we have in, let's say, 12 hours from now, or an estimation of how long it will take to collect all survey answers. For example, for 1,000 completes, given a specific targeting, we have an estimation of 2 weeks or 2 days. So to achieve that, we track on a daily basis the conversion rates for more than 30,000 variables. And that variables are a combination of demographic and geographic criteria, and we compute the conversion rates. The conversion rates is the ratio between the number of surveys completed by the respondents and the surveys sent to respondents. For all those rates, we update the corresponding exponential moving averages. So we have different moving averages for different intervals of time, let's say for 24 hours, 48 hours, 1 week, or even a whole month. And we combine all that information together along with time series of the demographic and geographical data in order to use a regression-based modeling and extrapolate and produce the feasibility estimations. Of course, in the presence of quotas, we still perform inside all that combination of algorithms, stratification, which is similar to the audience preview service that we saw on the previous slide. So once we have defined the audience, we need to create the questionnaire. And Pollfish here gives you a broad selection of question types and also research methods. So, for example, you can choose from a list of question types, like the simple one is the single selection, or multiple selection questions, or open-ended questions, or ranking questions, several other types. But more importantly here, Pollfish makes accessible advanced research methods to anyone. And one such interesting method is conjoined analysis, for which I would like to talk a bit more here. In brief, in conjoined analysis, we would like to ask respondents to make choices between multiple sets of criteria. And the goal is to understand which features are prioritized and considered important for the respondents. So for conjoined analysis, also for MaxDiff, which is a relating method, Pollfish automatically estimates optimal designs of choices by applying state-of-the-art methods for design of experiments. To understand the whole concept, I prefer to give you an example, as we can see here in the presentation. So let's assume that you're representing a bicycle company, and you are interested to ask potential customers about the preference in bike types, setups, and prices. So you have a collection of attributes, which is, as we can see in the example here, the type of the bike, like gravel, mountain, or hybrid, or the price of the bike. And for each such attribute, you have a set of possible values, which are known as levels. So the levels of bike type is gravel, mountain, and hybrid. And each combination of levels forms a concept. A concept is a possible bike setup along with its price. And all possible combination of levels represent the full factorial design, which is practically a Cartesian product. And two or more concepts form a choice set of alternatives. So, as we can see on the right, at the end, we would like to ask each survey participant to choose one concept for each choice. So let's say that we have three different bike setup, and the participant will choose the one that prefers more. As you can quickly find out, the full factorial design grows exponentially, which is, it was, as I said before, it is the Cartesian product of all levels. And on top of that, you can quickly find out that it is not practical to ask all possible choices to every survey participant. So with design of experiments, we are seeking to find an optimal design in order to reduce the number of possible choices, but we would like to keep the maximum possible variance in the set of presented concepts. In other words, all levels must appear equally among concepts. And still, I would like to able to estimate attribute importance without bias. So Pollfish combines optimization methods of exchange-based algorithms with linear programming in order to automatically find optimal choices and divide them to groups of choices, also known as blocks. And all such groups or blocks will be equally distributed among participants. So as a result here, instead of asking all possible choices, which is, as we said, not practical, each participant will get only a subset of optimal choices. So instead of, let's say, having 100 different choices, nobody is going to ask so many options. Each one will take, let's say, 5 choices, and each choice will have only 3 options. So it's something that it is feasible for the participant to answer. So finally, after having specified the target audience, the survey questionnaire, or setting up conjoined analysis, the researcher can preview and check out the survey. Now, let's see, let's ignore for a little the data collection part and see what is happening to the data analysis part. Once we are starting to collect responses, the researcher can go to the reporting dashboard in Pollfish and perform data analysis. Here's a screenshot of the dashboard. Specifically, the researcher can review aggregates of collected answers, demographics, geolocation, and also apply filters on them. In addition, the researcher can export the data in various formats and also use Pollfish to compute cross-depth tabulations, which is combinations of answers, demographics, or geographical criteria. And finally, Pollfish collects census data from some countries like United States of America or countries of the European Union, and gives you the ability to apply post-stratification in order to minimize discrepancies between the population parameters and realized sample characteristics. For post-stratification, as you might guess, we use the same methods for stratification that we use in the audience services. So let's go back to conjoined analysis, which is an important advanced market research method, but this time from the perspective of data analysis. In conjoined analysis, the goal is to compute statistics about user preferences over attributes. Specifically, Pollfish applies a variant of softmax regression to estimate these user preferences. So softmax regression is a multi-class logistic regression, and here the classes are the alternatives of the choices. So after having the design of experiments, we have optimal choices, and on each choice we have, let's say, 3 choices, A, B, C. These are the classes. Then estimated weights correspond to the level utilities. For example, we estimate a weight for, in our example, a bike having disc brakes, a different weight for a bike having cantilever brakes, and different weight for a bike that having front suspension, and so forth. After fitting the model over all the collected choices, attributes importances, for example, bike type or bike brakes, are being computed by their level utilities, and that is the weights of the model. So by having estimated all those weights, we can have some very useful insights and diagrams, as we can see here. So the diagram on the left presents the importance of its attribute relative to the others. So as we can see here, all values in that chart sum up to 100. And we can find out that price seems to be the most important attribute for the respondents, while front suspension seems to be the least important. Another example is the diagram on the right, which represents the marginal willingness to pay. Marginal willingness to pay is the indicative amount of money your customers are willing to pay for a feature compared to another one. For example, as you can see here, the customer seems to be willing to pay $11.5 more for disc brakes instead of cantilever brakes. So by finishing the 2 parts that researcher is being involved, it's time to see the final part and see what is happening during data collection. And perhaps, as you might imagine, a lot of things are happening in the background. Pollfish distributes the survey to the right audience by matching the demographics and geolocation data. Pollfish may distribute the survey to mobile devices either natively within the integrated application or using a kind of web-based integration. And also it may use other third-party survey networks. So imagine, for example, that you're using an application or a game in your smartphone, and instead of watching an advertisement, you can answer a survey. And for the first time that we see you, we're going to ask you some demographic questions in order to create a profile for you. And if we have a survey that matches to your profile, then we are serving that survey to you. And each answer that you are giving is being posted to our platform. So along with survey distribution, an important part is that we employ a distributed event processing system in order to evaluate the quality of every survey answering response. So the main question here is, why we have a system for fraud detection and data quality. There are two different perspectives here. Regarding fraud detection, for example, except from the possibility of having bots that will answer automatically survey questions, we may have users that would like to try to, they will attempt to change their identity, for example, by changing the device data or the integration data in order to re-answer the same survey, or by using proxy or anonymous networks to appear at different locations and able to be retargeted. On the other hand, from the data quality perspective, some respondents don't put much effort into answering your survey as they normally should. And also that behavior is also known as survey satisficing. For example, the respondents may not read the question and quickly or randomly choose an answer. So in such cases, we are interested to find out if the respondent answers abnormally fast, or respondents that we like to find out respondents that give generic answers or nonsense answers, or they follow some interesting patterns like straight lining. For example, they may always selecting the first answer, even though the answers that have been appeared to him or her have been appeared in a random order. Also, we like to find out participants that failing to answer some quality questions that we inject in the survey, or we may observe inconsistencies between the answers, the demographics, and the geolocation. So, since we are using an event processing system for fraud detection and data quality, the whole architecture of the data platform is strictly event-based. All events and responses are represented as events. We have several types of events. For example, we have signaling events to indicate, for example, that a device is connected to our network, or Pollfish starts to serve a specific survey, or a survey has been completed, and so forth. And also we have events for demographic answers, and more importantly, for ordinary survey answers. So all input event streams pass through data enrichment services, and thereafter from the distributed event processing system for fraud detection and data quality. All input events firstly are enriched with device metadata, for example, metadata related to the mobile carrier or the manufacturer of the mobile device. Another enrichment is to add any known past user data. For example, when we have previously seen the same device, we are not going to ask again for demographic data. Instead, we enrich the events with the already known past demographic information of the respondent. We also enrich the event stream with some important geolocation data. So the distributed event processing system, it's actually powered by Apache Flink, and we're using Apache Flink in order to achieve high performance and low latency, which are both required due to the high volume of events, and more importantly, we would like to have a responsive user experience. And at the same time, it is important to have a stateful event processing system in order to be able to perform complex join operations over asynchronous streams, as well as to remember past events or past fraud outcomes or any other past measurement that is useful for our system. So in general, we have two different levels of flow structuring our event processing engine. The first one is the one that is highlighted here, and it is responsible for applying checks before the questionnaire. That level has very strict SLAs, as we need to have a decision before giving a survey to the potential respondent. For example, we disqualify users from anonymous networks, private networks, VPNs, or when the same device seems to be appear to distant locations within short periods of time. We also search for inconsistencies between carrier data, device location. We also identify duplicate antennas, and based on past data, we also apply risk scoring, similar to credit risk scoring. And regarding risk scoring, it actually is the newest addition to our system. Here we would like to estimate a probability, the probability of getting a successful participation. So a participation that is non-fraud and also a good quality participation. And the methodology that we follow here is inspired by credit risk scoring. For example, in banks, for example, they perform credit risk scoring in order to approve or not a loan based on the profile of the borrower, and also based on recent data that they have for recent borrowers that have been, for example, defaulted. Here, we are using it to estimate the prior probability that the respondent is trusted to take a survey. The model at the moment is a binary logistic regression and is trained over user demographics, geographical data, device metadata. Also, we are using survey data and the integrated application data. The model is retrained on a weekly basis, and it is implemented using Spark ML pipelines. Now, regarding the supervision of the model, we have followed a hybrid approach. So part of it is synthetic from past outcomes of the fraud detection system. And part of it also has been manually annotated by people that review the results. So the resulting ML pipeline is served as a microservice, which is being used by the fraud detection system in order to score recent users before taking a survey. Regarding the second level, here we focus on quality checks over the questionnaire. And we're aiming to find out users that are speeding and therefore they do not pay attention to the questionnaire, find patterns like, as I said, straight lining, or applying checks over the open-ended questions. For example, make sure that we are not having gibberish answers or forbidden phrases or similar answers and repeated in the sense of spamming. We also have rule-based checks, which their expressivity is similar to propositional logic and can be specified at any time, either before or while the survey is running. They can be applied over the questionnaire of the survey, the geolocation data of the respondent, the demographics of the respondent, or any device metadata, and any combination of all of them. Consider, for example, that we would like to express a red herring question that is adding to a question a fake or an impossible answer as a selection. or we would like to disqualify when the respondent gives answers that are contradictory between different questions. So to conclude, so far we have seen that in this talk we have seen how optimization, local search can be used, also statistical and machine learning methods in order to automate, give useful insights, and more importantly, make market research accessible to anyone. So regarding future work, there are a lot of things that happening right now, and we know that a lot of things can be improved. We always seek for improvements regarding the audience services. We would like to add more and automate them, research methods to the platform, like we did with Conjoined Analysis. And finally, we actively working to extend our event processing platform for fraud detection and data quality. For example, we actively right now working on a new series of machine learning models that combine all those checks that we have, along with recent participation data. We are also considering to learn common rules in order to give quality filtering suggestion to the researchers. And another part is that we like to enhance some checks with NLP methods over the open-ended questions. For example, we are considering to the direction of semantic matching. For example, to understand that an answer is within the context of the survey. So I think that I'm just in time, and thank you for your patience, and I hope that you have found interesting all the presentation, and I will be happy to answer, if I can, any of your questions.
Thank you, Tasso. So everyone can write questions in the chat. I see the first question is by Fotis. So Fotis is asking exactly how the surveys are being distributed, I think.
Okay. So we are not sending the service on social media apps. Pollfish has two ways to be integrated, either using a web API or by providing an SDK for Android devices and iOS devices, in which the developer of the application or the game can integrate that SDK, that library, and instead of showing advertisements or how we like to have the experience, it can serve Pollfish surveys. I think, is it another part of the question? I don't remember.
I think that's, Poti, please confirm that this is what you were asking. I think that was the question. There is one question from our communication department here in the lab about whether there is a testing version or a validation version of Pollfish to use.
Testing version. So from the perspective of application developer to see how it's going to be integrated and.
No. I mean in terms of user, a researcher, market researcher.
A market researcher. We have some examples in the website of Pollfish. I'm not aware of having something like a demo account, but in such case, I think that by communicating with the support, they can arrange demo or perhaps, depending on the use case, they can arrange something like a demo account.
Okay, so I guess the answer is we have to ask for it. Okay.
Yes. I'm not aware that we have something like a demo account ready to use for anyone.
Okay. I have, okay, Alexandros is asking something. What are the challenges you have business-wise in explaining the unique selling product you're offering to prospective clients? So this is more for the marketing people. I don't know. Tassos is not really in the marketing, but maybe Tassos, you can say a few words about it.
Yeah, I'm not the right person here. It depends on the client, I think. For example, if the client is a traditional client that performs market research with more traditional ways, then the questions are about the quality and the accuracy of the whole platform. If it's from the perspective of the application developer, it's more technical, how to integrate, how it's going to be interchange messages with Pollfish. I don't know. I'm not the right person for marketing.
Yeah, I guess so. Okay. Until somebody else writes a question, I have a question about the filters or the criteria that the market researcher requests. How confident are you that the people you select who meet the criteria are actually truly have those characteristics that you think they have?
Okay, the easy case is to indicate some outliers. For example, to be very young with very high income and be a CEO of as a profession, be a CEO of a company and have 10 children, something like that. Okay, this is something that is an outlier. We also do the quality checks when someone gives the demographic. So those checks that we apply when we collecting answers from a survey, we do the same checks also when we are collecting demographic data. So someone chooses something randomly or fails to answer a quality question that is being injected internally. And the other part is that we have several surveys that they ask for demographics also from clients, that they ask the same questions or similar questions within the survey. And we can verify that, let's say that someone says that it is unemployed and the survey is about a specific profession. So in that case should be disqualified, that user, and we can find that user, not the same user, but we can find the response. So there are a lot of things that we test the quality and give us confidence that we collect correctly the demographic data. Also, I would like to say that, for example, there are other cases like someone says that where lives, and we can see that based on the IP address, the location is somewhere else at the moment, that in a different country. So in that case, we are not going to activate that profile until we see that appears in that location. There are several things that can be done.
Are you doing any outlier detection to to find out whether, statistically, are you looking to see how close somebody is to the rest of the people with similar characteristics in terms of the answers that they provide?
We do some checks periodically to evaluate that the demographics that we have for by country, for example, are in the same order regarding the census, and also we see the values that we have for all those criteria. We see to identify outliers. Yeah, we see, and we have seen in the past outliers in several cases. And when we find outliers, we usually try to adapt the system in order to not have some similar incidents in the future.
But you don't use that to deactivate some users or some responders?
In that case, we can do that. For example, we can disqualify permanently some profiles in that case.
And do these disqualifications have to go through a manual selection process, or is it done automatically?
Okay, so if something that it's quite new, it is an outlier for everyone. So in that case, it's going to be first a manual process. But after that, we usually adapt the system in order to not do that again. So, for example, let's say that we can add horizontally some rules about the demographics, that some impossible combinations of demographics that does not make sense. And they automatically then apply it to every running survey. And this is also, as I said at the end, for the future direction, we're thinking of do a bit more about this, to learn rules and make suggestions to the researchers. For example, they can add a red herring question in that case easily.
Okay. And there's a question from George Giannakopoulos. Do you believe there are ethics concerns related to the systems you built? And is there an internal process to validate such ethics concerns?
Okay. Okay, regarding the data that we have in the profiles, we don't know, for example, we don't have subscribed users in which we know, for example, their email address. We don't have that. And the participation, that's why we say about the participants, not actually users. They're participants and they participating to a survey. And that is done anonymously. So we don't know any, we don't have any sensitive information about the users. They consent to give some key demographics, for example, the year of birth, which is important. You cannot proceed with a survey and have very young people to answer it. So I think that we don't have any issue about this. And the other part is if, for example, a user of application wants to, to forget him, we can do that. So we can forget all the demographics and anything that points to its participations.
I suspect that George does not mean only the handling of personal data. Maybe he also meant
about the questionnaire. Maybe if,
yeah,
for example, if it's about the questionnaire, we have a process that we review the survey. So it cannot just someone ask anything and just hit a button and start running a survey. There is a review process.
What are the things that are not allowed to do? Can you give us an example?
An example. If someone asking something that is not allowed to a specific country, for example, in our case, in Pollfish, we do not ask all the demographic criteria to every country. Some countries have different regulations, and also you have to follow that regulations within the surveys. If the survey implicitly asks something that is sensitive, then it should be, it cannot be approved.
This can be difficult sometimes to judge, I think.
That is true. The work of people that read the survey, I think, is quite stressful, and it's complicated for them.
Okay, I think we have to stop here. Thank you, Tasso. Thank you very much. It was really very interesting. Thank you also for the discussion. It was really a pleasure to have you again with us. And I hope we see you more often, especially as we start moving outside our houses a bit more. All the best with what you're doing, and all the best to the company. And also, you know, you can also let everybody know that this series of talks is open to everybody. It's not just for internal audience. Anyone who wants to participate is welcome. And actually, many of our participants today were speakers of previous similar presentations. So I think this is very interesting to create to start a discussion also between companies that use such technologies. Thank you very much.
So thank you for giving me this opportunity, and also anyone that would like to ask about that presentation, we can do. You can reach me out, and I will be happy to answer any question. Also after this presentation, and also I will be happy to do again a presentation or to collaborate in some other talk.
Thanks.
Thank you.
Have a good day. Thank
Okay.
you, everybody. Bye-bye.